So for this, we're just going to kind of go through the conditions for each one of these and kind of some of the more mechanics-based things, okay? So your statistic, if I'm doing a one sample Z interval for a proportion, my statistic is P hat, my parameter is P, okay? And your P hat you calculate by doing X over N. Your parameter is the true proportion of blah, 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 okay? All right, the conditions to do, and then likewise, my statistic for a 2 sample is P hat 1 minus P hat 2, trying to make conclusions about P1 minus P2, okay? All right, your conditions your first condition is random. Which you're going to say given somehow. Your normal condition. For this one, you do N P hat and 1 minus P hat. Again, they have to be greater than or equal to 10. And if you have to, you've got to check for both samples. And for independence, you're going to have 2 possible things. You're either going to do N is less than 10% of the population, or individual responses are independent, depending on how you check your random condition. All right. The calculator command for these is all of these are in the test menu. You're going to choose 1 prop Z int or 2 prop Z int. Now, remember we talk about our our spots where we have check or choose, check, calculate, conclude, right? Those are our 4 C's. For the choose, you have to use the official name. Don't use the calculator. I should never see this part written on your paper. I should see these ones written on your paper. Use the official name, not the calculator name. Okay? But your calculator can't fit that on the screen. Every okay? All right. If, for some reason, you don't really have a time. Okay. If for some reason, okay, you have to fill these in. In other words, I'm thinking in the multiple choice section where they give you like the different things filled in. Okay? In general, confidence intervals are the statistic plus or minus a critical value times the standard error of the statistic. So, for this one, I don't really have a good space here for this. That would look like, it's probably P hat plus or minus Z star times the square root of P hat 1 minus P hat over N. For the other one, it would be, your statistic is P hat 1 minus P hat 2 plus or minus Z star do better about spacing. Now, these are not on your formula sheet, but this is. So if you know the critical value is z, that tells you that this is a z star. So you got to know like that. You got to know that to estimate p1 minus p2, you do p hat 1 minus p hat 2, right? That is your statistic, right? Okay. All right. What is your statistic if I'm doing means? A one sample mean. What's the statistic? X bar. With my parameter being mu. If it's two sample, it's x bar 1 minus x bar 2. My parameter being mu 1 minus mu 2. Okay. So if I use that exact same thing, x bar plus or minus, now what is my critical value? T star, because it's AT, it means go with T. And my standard error is S over the square root of N. If I have two samples, my statistic part will be x bar 1 minus x bar 2 plus or minus T star. You'll never do this one, but technically it's this. Okay. Conditions? First one is random. Normal, independent. Random will be given. Normal is still, or independent is still n is less than 10% of the population. Or individual responses. Are independent. Your normal and greater than or equal to 30. If you have two samples, you check that for both samples. What if your sample size is not greater than or equal to 30? You look at a graph of the sample itself, and the sample suggests that the population is approximately normal kind of thing. So we're going to say no major skewness in sample. But Bruno, you bring up a great point. When we talk about conditions, if the conditions are not met, you're going to say must assume. You are not going to stop the question, okay? They're not trying to trick you. You're probably missing something if the conditions are not met. If they're trying to get you for the conditions are not met, what they will say is it'll be like it won't be just a run the test or run the interval. It'll say explain, part A will say explain why we might not want to run a explain why a two sample t interval is not appropriate in this setting. It'll say something like that if the conditions are not met. But you're in the grand scheme of things, if the conditions are met and you can't see how they are met, the calculations in the conclusion are worth 2 of the 4 points of the question. So to not run is a bad idea. And they're not trying to trick you. Everybody okay? You're better off. Speaking of, what if you can't remember which test to do? What should you do? Make up a p-value. Why should you make up a p-value? The conclusion is worth 1 point every single time. And if you make the correct conclusion based on the p-value you've found, you get credit for the conclusion. Do you guys see what I'm saying there? So, and they don't say, do you come to the conclusion that the test should? Does your conclusion match the p-value you found? So if you don't know how to do anything, the least you could do is say my p-value is 0.94. Because 0.04 is less than 0.05, I reject the null hypothesis and conclude, and then just steal the wording from the question. If there's a significance test, you should at least get 1 point on every significance test just by making up a p-value and making a conclusion. Now, none of us want 1 point, right? We want all 4. So you got to do the other stuff to get all 4, but we can at least get the 1, right? Is everybody good? Just make it up. If you're completely lost, make up a p-value, at least. Okay? They're also really good on, like if you get part A incorrect, you're not going to lose points all the way down. If you use your whatever value you get in part A, and you need to use that in part B, as long as you use it appropriately, you're fine. You're not going to get double dinged for a mistake. Okay? So if it ever says using your answer in part A, you won't get credit if you don't use the answer you put in part A. So don't leave it blank. Put something there. Usually this kind of usually applies to like probability questions. Put something there and then use it appropriately so that you get points for the second one. Does everybody get what I'm saying there? Okay. In the calculator, this one's a t-interval. This one is a t-test. All right, we do confidence intervals for slope. Your statistic is B, your parameter is beta. We do B plus or minus T star times the standard error of beta, which we get from the table. The conditions for a T interval for beta. This should say T interval or T test. That's fine. Independent. Normal. Equal variances. This is the liner. I'm not going to spend a ton of time on it because because you're not going to be asked to do this. Again, if you are, I'd bet thousands of dollars if I had it, but I don't, so I'm not going to bet that much money. You're not going to be asked to do that. Technically, we've never used it. There isn't a linear regression T interval. It's at the very, very end. You won't have to do it, though. We use the table. And also, I light up here. This is a 2-sample T int. So as we're looking at this, if I go over to tests, you can kind of get a feel for everything, right? So there's the 1 prop Z int. There's the 2-sample T int. Everybody good? And you guys, as I'm looking at my calculator and I'm like, I can't remember if proportions are Z or T. Can you guys see how the calculator can remind you that proportions go with Z? Is everybody with me? Because it tells you prop Z, they go together. Everybody good? I'll stop on the intervals today. We're going to do the tests tomorrow. There's a few more of tests than intervals. All right. So, yesterday we talked about like all the different formulas for and conditions for confidence intervals. Today I'm just going to do the same thing for tests. We're going to talk through what should your hypotheses be, what is the formula that gives you your test statistic. We're going to talk about conditions, okay? If my null hypothesis, my null hypothesis in a one sample Z test for a proportion will be some version of P equals something, right? And that something is always going to be some values less than 1, okay? So for right now, I'm going to call that P equals P sub 0, which is just whatever the P of the null hypothesis is, okay? So it could be 0.25, it could be 0.73, it could be 0.62, whatever, okay? All right. Now, the test statistic we get here, so a reminder that a test, and again, this is on your formula sheet, this is making sense of how to use your formula sheet. Your formula sheet says something like the standardized test statistic is your statistic minus the parameter divided by the standard error of the statistic, okay? So what is the statistic that goes with the parameter P? P hat, okay? And so statistic minus our parameter is our hypothesized value of our parameter, which is the P from the null hypothesis, over the standard error of the statistic is we use whatever our hypothesized value is. Everybody good? All right. Now, your conditions. Random. You're going to say it's given. Your normal condition here, again, if we have a hypothesized value for P, we use the hypothesized value for P. For independence, N is less than 10% of your population. How are we feeling, okay? In the calculator, we pick the one prop Z test. A reminder, we do this. In terms of when we write down which procedure we're doing, we write down the name, the proper name, not the calculator name, okay? If I'm doing a 2-sample Z test, All right. You guys saw I just took one of your formula sheets and took a picture of it, right? Okay. So your Z statistic for these ones, and again, the only time you're going to have to worry about this formula, but it could happen, is on your formula sheet, which is on your formula sheet, is in like a multiple choice question where they have the formula filled in. Okay, so, but when you'll see that it says when P1 equals P2 is assumed, we use a different standard error formula. We use this one. Is everybody seeing it? Okay, and notice that this is where you can see that combined P hat formula and how to find it. Okay, so my statistic is P hat 1 minus P hat 2 minus my parameter. Well, what is my parameter? My hypothesized value for the difference between our two samples is 0. So what is that really, y'all? It's just P hat 1 minus P hat 2 over P hat C 1 minus P hat C. But this can also be your reminder. So if I do my conditions here, random is still going to be given. Your normal condition here is that you're supposed to do N1 times P hat C. And do the same thing for N2. But this is the place where you're supposed to use that combined P hat. So in some respects, I would have like the reminder comes back to this statement here on your formula sheet that when you are assuming P hat or P1 equals P2, which only happens in a test, that you're supposed to be using P hat combined for everything. Okay. Now the easy part, the calculator part, is 2 prop Z test. What happens if you can't remember? You have a test and you can't remember which one to pick, or you can't remember what your p-value is. What should you do? Make one up. Always make one up. Same with a confidence interval, by the way. If you can't figure out a confidence interval, make one up. If you can't figure out which one to use, or you can't, because if you interpret whatever interval you found correctly, you get credit for the interpretation of the interval. Okay, so even if it's the wrong interval, get at least credit for interpreting it. Okay? All right, let's keep moving. Oh. But this formula that is on your formula sheet, this one, you can connect that to x minus mu over sigma for a z-score, because they're the same idea. Observed minus mean over standard deviation. The statistic is what you observe of your sample. The parameter is the center of the sampling distribution. If the null hypothesis is true, standard error is standard deviation. So it's kind of on your formula sheet. All right, my null hypothesis, if it's a okay, you do the same thing. Whether if it's a paired t-test versus a one sample t-test, it's the same procedure. You pick t-test in your calculator, okay? And your z statistic then would be, all right, well, so your statistic would be x bar minus mu over the standard error of the x bars is s over the square root of n. That's really hard to see. Everybody okay? By the way, y'all see, do you guys remember doing z-scores a long time ago? Like at the very beginning of the year, we said our z-score was the observed minus the mean, all divided by the standard deviation. The z-score formula is not on your formula sheet, but do we see that the sample minus the hypothesized value is the same idea as observed minus mean? Divided by the standard error. Like, divided by the standard error is the same thing as being divided by the standard deviation. Like, I couldn't teach it to you then. All right. Conditions. Is anybody shocked? Random. Normal. What was the normal condition for means? N is greater than or equal to 30. Or graph shows no major skewness. Graph of the sample shows no major skewness. Independent. N is less than 10% of the population. Or individual responses are independent. All right, if I'm doing a two-sample t-test, my null is mu1 equals mu2. Another way I could write that is mu1 minus mu2 equals 0, which makes my A. Oh my goodness gracious. Y'all. We should have a problem with this right here. What should this be? This should be T. Again, my intention with giving you each of these like formulas for those test statistics, you don't need to use those formulas unless it's like it's filled in a multiple choice question. You have to pick which one is the formula filled in the correct way. Okay, that's the only reason I'm pointing these out. And then this one's you pick t-test, this one two-sample t-test. All right, if we're doing a t-test for slope, my null hypothesis is going to be beta is equal to 0. My t statistic technically is b minus 0 over a formula that you will never ever possibly use, but I'm giving it to you because it's the formula off your formula sheet. You will never ever ever have to use that. All right, your conditions are linear. The same ones as above, okay? And technically in your calculator, again, you won't be using it. There is a Lin Reg t-test at the very bottom, but you won't be using it, so don't worry about it. Almost done. All right. Okay. All right. Chi-square test, there are no formulas for your test statistic other than chi-squared equals the sum of observed minus expected squared over expected. Don't. Okay. Your null hypothesis for a goodness of fit test is like P1 equals, P2 equals, P3 equals. You could put that in words and saying that the population follows a stated distribution. Because like typically a stated distribution would be like 15, the example like we used in Columbus, like when I think it was on your quiz review, in Columbus, 85% of residents say that the Buckeyes are their favorite team, 10% say the Blue Jackets, 15%, etc. Right? That's like a stated distribution that we're trying to compare to, okay? All right, test for homogeneity. The distribution of, and I'm going to say blank, is the same across So chi-square for homogeneity is the one that comes from multiple populations, either from different regions or different treatment groups, okay? So like we used an example of like a good test for homogeneity. We like if it's for an experiment, the example in your notes was like people who listen to classical music versus jazz music versus no music, and the percentage of people who finish, or the distribution of test completion is the same for each treatment group versus, or for each population, okay? And very similarly, if it's a test for independence, you're going to say the variables are independent, but you're going to do that in context. Another way of saying that is there's no association between my variables, okay? So independent equals no association. All right. Conditions. Random is still going to be given. Is there a normal condition? Nope, in this one it's large sample size. And that means all the expected have to be greater than or equal to 5. And independence is the same independence. Everybody good? This one is chi-square GOF. This is chi-squared test, chi-squared test. Okay. Now, in a few seconds here, I'm going to post in the updates in Schoology a link to a practice assignment. What that practice assignment, all you have to do in that practice assignment is choose the procedure. That's it. On Monday, you're going to have a quick little a classwork for a homework grade assignment where I'm going to give you a list of things and you're going to have to name the procedure and check the conditions, and then I'm going to make you do 2 total all the way throughs. 1 for a confidence interval so that you have to show me interpreting a confidence interval. 1 for a test so that you have to make a conclusion from a p-value. Okay, so let me get that put up on Schoology for you guys to get some practice, and then we'll be done.
Is there an independent condition for the 2 sample Z-test?
Yeah, it's the same thing. You're just doing it for both samples. Yeah. It will be on Schoology, but it's not there yet. All right, it should be up in the updates on Schoology, y'all. Let me know if you have trouble.
Another charger.
I really, I have my iPad charger works as one, and I'm done using my iPad.
Are you sure?
Yeah.
Thank you.
Don't let me forget to plug my iPad back in.
Okay.